When I was a kid, my dad was, imagine that, a high school math teacher. And he was chair of the math department at the local high school for many years. And every once in a while, he would come home with the latest calculator that the department had bought. Now, you got to remember, this is back in the early, well, late 60s, early 70s. Um, and so the calculators were big. I mean, the one I'm thinking about is it was briefcase size. This thing was briefcase size. It was the first scientific calculator that they had. By scientific, it means it had not just add, subtract, multiply, and divide, but it had other things on it. It had exponentials and logs and trig functions and things like that on it. The display on this thing was a line of essentially light bulbs, and each light bulb had 10 different filaments in it. And one filament was the shape of 0, one filament was the shape of a 1, one filament was the shape of a 2. And so you, depending on what number was being displayed, it was just a different filament lit up. And then as you read the number going across, it kind of came in and out at you because the different filaments were at different depths in the light bulb. It was kind of crazy. But it was fascinating to this little boy, as I have no idea how old I was. I can remember it, so I was probably at least 4, probably like 5 or 6. I have no idea. But I remember just pushing the buttons, and the thing is, as it calculated, it was nowhere near as fast as things are today. So it would think for a little while, and it was thinking, the light bulbs were all part of the process, and that it would sit there and flash and flash and flash, and then poof, it would come up with an answer, and you'd do something else, and it would think and flash. And what was really cool was that you got to remember, this is like a 5-year-old kid. I must have been a little older than 5 years old, though, because so maybe I was more on the 10 because I was really fascinated with 3 of the buttons that were on there. They had sin, cos, and tan on there. You got to remember, I didn't know what sine, cosine, tangent were. To me, it said sin, cos, and tan. I really wasn't going to push the sin button, at least not if Dad was looking. And then the cos button. There was a girl in my class, Susan Coswell, and her older brother played on the high school basketball team. And with my dad being a teacher at the high school, we quite often went to the high school basketball games. So at least I knew the names of the guys on the team. And one of them I knew because he was the older brother of a classmate. And everyone called him Cos, right? He was Steve Coswell, but he went by Cos. And it's like, man, he's got his own button on this machine. It was awesome. The Cos button. And I would spend time with this calculator, pushing the Cos button. And the effect is this. This is a TI-84. But I put in any number. Put in 2, right? And then I want to know what's the cosine of 2. So I'm just doing this as cosine of answer. The notation, whoops, what did I just do? Yeah, cosine of answer. The notation was a little different. That rather than saying cosine of 2, on that calculator you'd hit 2 and then you'd hit cosine, right? And it would take the cosine of whatever number is already being displayed. But I set it up this way because it's the same effect. If I do this, cosine of 2, right? It gives me negative 0.4 whatever, right? And then what I would do as a kid is I just push the cosine again. So it would be taking the cosine of whatever number I had there. Of course, the lights would flash, and then it would give you this answer. And then you press cosine again, and the lights would flash, and enter. And you do it again, and again, and again, and again, and the lights would just flash. It was mesmerizing. I didn't know what I was doing, but I did know that if I pressed cos enough times, I would get a stable answer. Right? That eventually, I'm almost there, that the output would be the same as the input. There we go. Okay. And it didn't matter what starting point I had. I could just keep pushing cos, and I'd end up with this same 0.739. I don't remember that that's what the answer was, but I just knew that I'd go get the same answer every time. I'm sure that it was 0.739. You can do the same thing with sin, as long as nobody's looking, and it goes to 0. It takes a long, long time, but you could do the same thing. And I was doing Picard's method, and I didn't know it. The thing is, here we go. Picard's method that we're doing in differential equations is actually an application of more general Picard's method for solving equations algebraically. Not algebraically, but estimating, numerically solving algebra equations, right? And the thing is, the algebra equation is if you have an equation that looks like f of x equals x, so some function of x equals x. And what we're doing is we're saying take a guess, plug it in for x, and then look at the output. Well, if the output is the same as the input, you got it right? If it's not, then take that output and plug it back in again. Take a look at the output. Is it the same as what you plugged in? If not, plug it back in again. And you just keep going around in circles, doing this again and again and again. And the idea is to find the x that satisfies that equation. So what I was doing with the calculator was I was doing Picard's method on the equation cosine x equals x. I didn't know it then, but I know it now. Anyway, there you go. Story from my childhood.